Society or biology? Nature or nurture? What makes us, us? Hi, I'm Jordan Og, and welcome to my brief crash course on the chemistry of our minds. Today we are going to be looking at the biological basis of schizophrenia. As a bit of a background, schizophrenia was originally discovered in the early 20th century, where it was described to be a split of various mental processes, such as memory and perception. Now, schizophrenia is primarily defined by the criterion described in the DSM-5, which basically details a lot of other psychopathology. This includes nonconformity, distress, and malfunction within society. Schizophrenia includes positive symptoms such as delusions, hallucinations, and negative symptoms such as alogia and speech poverty. We are going to be looking at the biological basis of it and what creates it and what our brain is doing during it.
One of the patterns we see is in the ventricular system. In the lateral ventricles of our brain, we see cerebrospinal fluid, a clear fluid that provides cushioning to the brain, circulates nutrients, and removes waste from the brain. In people with schizophrenia, the lateral ventricles are larger. People with larger ventricles may not experience antipsychotic drugs as effectively. The protein DISC1, disrupted in schizophrenia 1, is a mutated protein in people with schizophrenia. DISC1 typically regulates trafficking of molecules within neurons. In one experiment by Pletnikov in 2011, rats were injected with DISC1. These rats began to develop larger lateral ventricles, as seen in scans of individuals with schizophrenia. One thing we see is a lesser activity in the temporal lobe, as discovered by Minzenberg. If you look on the right, there is a lesser activity seen in the temporal lobe, which is in charge of human expression, decision-making, and regulation of emotion.
There are two primary developments within antipsychotics, one being the dopamine hypothesis. The dopamine hypothesis is seen within chlorpromazine, which is the first generation of antipsychotics. This reduced the positive symptoms of schizophrenia, such as delusions and hallucinations, if you recall me saying that, and it actually gave negative side effects, such as tardive dyskinesia that was seen in involuntary motor control. This dopamine hypothesis is seen in antipsychotic drugs that block postsynaptic D2 receptors. This means excess dopamine release in people with schizophrenia. We also see the glutamate hypothesis, which is seen in PCP. This produces both positive and negative symptoms of schizophrenia. It is an NMDA antagonist and blocks central calcium channels. This shows that schizophrenia may be an underactivation of glutamate, which accounts for decreased activity in the frontal lobe.